7.9 magnitude.
That skull is rising following a major earthquake that shifted the source destinations of Pangasinan.
Earthquakes can happen anytime, anywhere in the Philippines.
And are caused by the sudden release of energy in the Earth's crust, producing seismic waves that can damage structures. With the Philippines being located in the Pacific Ring of Fire, it makes it prone to earthquakes and other seismic activity.
The Philippine Institute of Volcanology and Seismology warns that a future magnitude 7.2 earthquake along the West Valley Fault, known as the Big One, could collapse over 168,000 buildings and cause over 23,000 deaths in densely populated areas.
Many buildings are vulnerable because they're constructed with low-quality materials. As a result, search and rescue operations become more challenging, highlighting the need for earthquake preparedness and response.
When buildings collapse, debris makes it hard for rescuers to find victims. Concrete and wood block sounds, hiding cries and movement, which delay rescue efforts and costing lives.
Under rubble, through chaos, through silence, there is hope. Introducing MiraScan, a human life detection device utilizing millimeter wave sensors for debris rescue operations.
Did you know the name MiraScan reflects its components? Mi for millimeter wave, Ra for radar, and Scan for its scanning functions.
MiraScan functions similar to a metal detector, utilizing a millimeter wave sensor to detect the presence of a human being. It is designed in the form similar to a radar gun.
It features an LCD module display slanted at a 45-degree angle for easy viewing, while two bubble levels on the side and top ensure for steady handling and for more accurate scanning, as well as the prototype is encased in plastic with a rubber handle.
At its core, MiraScan uses an RD03D millimeter wave sensor, which maps a 120-degree wide and 8-meter-long area to detect humans, and it is powered by two rechargeable 3.7-volt lithium-ion batteries.
When switched on, power is supplied to the ESP32, which serves as the main controller. The ESP32 communicates with the radar sensor, which detects motion and presence using radar signals. Data from the sensor is sent to the ESP32 for processing, converting it into information such as distance, angle, and movement. This processed data is then displayed on the screen as a radar-style output, allowing the user to see what the sensor is detecting.
Here is how MiraScan works. First, you turn on the power switch to turn the system on. Then, point the radar at the area of coverage. The radar itself will scan through the area, detecting any people hidden under debris. Then finally, the sensor would read the information gathered, and the user will be able to interpret the given information.
MiraScan keeps users and victims safe by detecting people under debris without disturbing unstable rubble, reducing the risk of further collapse. It sends waves just 4 millimeters in wavelength to penetrate most materials, enabling it to detect survivors trapped under debris and potentially saving hundreds or even thousands of lives.
MiraScan relates mainly to SDGs 8, 9, 11, 13, 16, and 17 by improving safety for rescue workers using innovative technology and strengthening emergency response systems.
With that scan, can find those hidden under rubble, turning uncertainty into hope.
One small device can turn into bigger ideas for a safer, stronger, and smarter tomorrow.
We are the BRYGHT team,
Proud to contribute in saving lives for a better and safer future.